Hello guys, welcome to my channel Maximum Math Games. The question of the day is, what is a Sudoku or better called mini Sudoku? What is a Sudoku and how many possible Sudokus exist? Now all of you know what a Sudoku is. So this is called a Sudoku. Okay, you must have seen it in newspapers or somewhere else. And this is of dimensions 9 into 9. That is, there are 9 squares over here and 9 squares over here. So this is of dimensions 9 into 9. And a Sudoku is nothing but a mini Sudoku, that is like this, and this is of dimensions 4 into 4. So a Sudoku is of dimensions 4 into 4. Okay. Now let's see how many possible Sudokus exist. Okay. Now this square is a perfect square for a Sudoku. Okay. So what we do is, if we break down this original square into 4 smaller squares like this, then you observe that in each smaller square there is a yellow square, there is a blue square, there is a orange square, and there is a green square. Okay. And similarly for this and this square also. Okay. And moving further, we observe that if we break down the original square into 4 columns like this, then each column contains one yellow, one orange, one blue, and one green square. Similarly, if we break down the original square into 4 rows like this, then each row contains one blue, one yellow, one orange, and one green square. Now let us check out a few examples of a Sudoku. So this is a solved example of a Sudoku. This Sudoku can be solved either by using digits or numbers or alphabets or any other thing, be it symbols also. Okay, but the most popular Sudoku is by using numbers, that is 1, 2, 3 and 4. Alright, now let's see how many possible Sudokus exist. So how many possible completed Sudokus exist? Now to be able to solve this question, we are going to highlight this smaller square inside the larger square, and we will observe that this place can be filled in 4 ways, this place can be filled in 3 ways, this place can be filled in 2 ways, and this place can be filled in 1 way. Okay, so the multiplying factor is 1 into 2 into 3 into 4, and that comes out to be equal to 24. Now let us suppose that we fill these elements like this. So 1, 2, 3 and 4 or in these places. Okay. And now what do we have? We have these 2 places that we are going to target. So these 2 places can either be filled like this 3, 4, or these 2 places can be filled like this 4, 3. Similarly, our next target will be these 2 places, and these 2 places can either be filled as 2, 4, or it can be filled as 4, 2. That is, there are 2 ways of filling these squares and there are 2 ways of filling these squares. So the multiplying factor will be 2 into 2, that is equal to 4. Now let us assume that we fill it like this. So we have 3, 4, 2 and 4. Now the problem is, how are we going to fill these squares? Okay, and what are the number of ways of doing so? So what we are going to do is, we are going to target this particular place over here, and you observe that this place can either be a 1 or this place can either be a 2. Now let us take the case when we have 1 in this place. So if we have 1 in this place, then this is going to be a 2 over here. Okay, this is very obvious, and obviously this can neither be a 2 because we already have a 2 in this row. This can not be a 4 because we already have a 4 in this column, and obviously it cannot be a 1. So this place will obviously be a 3, and there is no other possibility of doing so. Now this place will obviously be a 2 because we already have 1, 3 and 4 in this column. So this can only be a 2. There is no other possible way by which this can be filled. And then 4 cannot come over here, neither can 2 or 3. So this place has to be equal to 1, and thereby implying that this place has to be equal to 3. Now it is very simple. In this row we have 1, 2 and 3. The only digit remaining is 4. So we write 4 over here. And in this row we have 2, 3 and 4 and the only digit remaining is 1. So we put a 1 over here, and this is the only way by which this square can be filled. Okay, now let us take the case when we put 2 in this place, okay, in this place. So there are two possible ways by which this question can be solved. The first one we will write over here and the second one over here. Okay, so if we have a 2 over here, this automatically implies that this is going to be a 1. Alright, now if you observe in this column we have 1 and 3 automatically, okay, and we have 2 over here. So this simply implies that this box over here can only be a 4 and no other possible numbers can satisfy this box. Okay, so we have 1, 3 and 4 in this column, so the only possibility is 2 over here, so we write a 2. And now what we are going to do is we are going to write down these digits for this square also. Okay, so we have 3, 4, 2, 1, 4 and 2 in this column. Okay, now the only possibility is if we write a 1 over here, then we will get a 3 and thereby we will get a 1 over here and there are 3 over here. Okay, now the other case can be that instead of writing 1 over here, we can write a 3. So if we write a 3 over here, okay, so we will have 1, we will have 3 and finally a last digit, that is 1. So this is one case, this is the second case and this is the third case. So there are three possible cases. So the multiplying factor will be 3. So now to find the possible number of completed Sudokus that exist, what we do is we multiply the multiplying factors that is found earlier. Okay, so the first multiplying factor was 24, the second multiplying factor was 4 and the third multiplying factor is 3. So the possible number of completed Sudokus that exist are 24 into 4 into 3, and this will give you the answer as 288. And that, my friends, is the answer to the question of what are the possible number of completed Sudokus that exist. Alright, thank you.